This is question number 2. A Pelton wheel with 2 jets need to produce power of 5,510 kilowatt and rotates at 329 RPM. Water was supplied with pipe system of length 1,000 meter from a tank located 350 meters from the nozzle. CV is 0.97, the phi is 0.46, overall efficiency is 85%, and Darcy coefficient is 0.024. Friction loss is 5% from gross head. Determine the nozzle diameter, the radius of Pelton wheel, and the diameter of delivery pipe. So here, please, I hope you could understand that. The 350 meters here is the elevation, mean the height of the level of water here until the center line of the pipe here of the input of Pelton wheel. Okay, however, the 1,000 meter is the pipe length. It is totally different because last time we have a complaint from the student, the height and the length is not tally. So you need to understand the height is the vertical distance. Okay, that's one. And then from this equation, I hope you could make your revision on major and minor loss from fluid mechanics 1. Because normally in Pelton wheel, we will use that idea. Here in this question, you have Darcy coefficient. So the Darcy coefficient is the value of F in fluid mechanics 1. I think you already know how to determine the value of F from the Moody chart. Okay, so that is the F, so the Darcy coefficient. So again, I would like to remind you here, in fluid mechanics 2, normally we will use the full term. So we don't use the F, we don't use beta 1, beta 2. We will tell you the exact meaning of certain symbol. Okay, so means we have the overall efficiency, we not write as eta and so on and so forth, because we want to make sure that students really know every term used in this topic. So and then this is I just shortcut the equation, the question. Okay, actually this is one of the final exam questions on that time. So we explain everything in words. Actually, we say it is at a speed ratio with 0.46 and so on. Okay, so I hope you spend your time to do some revision about minor and major loss. Okay, so we go for nozzle diameter here. So we know that the effective head, we need to calculate the effective head because from the question, it says that friction loss is 5% from the gross head. So this is the basic idea, means that 5%, this 5% is actually the friction inside the pipe, the major loss inside the pipe. So and then the CV here is the losses when water jets travel from the nozzle to the bucket. Okay, so and then the phi here is actually the ratio between the wheel speed here, so and the velocity of jet. Okay, so means that we need to calculate the effective head to calculate the velocity that hit the jet. Okay, it means the effective head at this moment. Okay, so means that, so because the friction is 5%, so it is 0.95 from the head gross. So we have 350, we time with 0.95, so means that the effective head at the nozzle here is 332.5 meters. So and then because water travel from the nozzle here to the Pelton wheel with certain losses, so we calculate the velocity of jet that hit the Pelton wheel here by using this equation. So we have CV square root 2GH effective. So this effective is the effective head at the nozzle here. So we have this one. And then we could determine that the velocity of jet that hit the bucket is 78.35 meters. So and then again, the question is about the nozzle diameter. So it's closely related to the flow rate. So however, so we don't know the flow rate, so we need to calculate the flow rate. So we use the overall efficiency here, and then we could calculate the flow rate because everything is given in the question. So we could get the flow rate here is the 1.99. So I take as 2 meter cube per second. So this flow rate is actually for the main pipe. So and then we are now calculating the nozzle diameter. So nozzle diameter means after the main pipe split into two. So the nozzle diameter means at the end of each pipe. So because we have two jets here, so we divide into two. So we have 1 meter cube per second. And then we could use this equation. So I think I already explained it in my previous slide. So we could calculate the value of diameter of nozzle here is 0.127 meters. Now we need to calculate the radius of Pelton wheel. So we have this speed ratio because in speed ratio we need to know the speed of the wheel and the water jet. It is given that the phi here is 0.46. So we know the water jet is 78.37, means that the velocity of wheel is 36.04 meter per second. Now from this equation, I think you're already familiar with this one. We could calculate the diameter of the wheel is 2.09 meter. So because the question is the radius, so it is equal to 1.045 meters. So number 3, the diameter of delivery pipe. So the delivery pipe here means the main pipe which carry the water before it split into two jets. Okay, from the question, it says that 5% is actually loss, and that loss is the major loss. So we could say that 5% from the total head is 17.5 meter. And this is the major loss. So we could ignore the minor loss. It also not given any information about minor loss in this question. So we just assume that it is okay for us to calculate only the major losses here. So the equation for major loss is like this one, F L over D V square over 2G. Okay, please make sure that you really understand the V here is the velocity that flow inside the pipe. So we have a main pipe here, and then it's split into two jets. Okay, you must know that in this pipe, it has flow rate. And here, it will have another flow rate. So this is Q1, this is Q2. Okay, because it is split into two, so we could write the total Q here is equal Q1 plus Q2. So this is the basic one. So because we are calculating the major loss here, the major loss inside the main pipe, mean the delivery pipe. So means that the flow rate here, the Q or the velocity must be velocity inside the pipe. So if you see from our previous calculation, we don't have that velocity. We have velocity as velocity of jet. So this is totally different. Please do not add these two value and assume it is equal to this one. No, because velocity is vector. You cannot just add vector like that one, okay? So, but, okay, from the continuity equation, we know Q is equal AV. So in this situation, because we don't know what is the velocity inside this pipe, so what we could do is, okay, we could use the idea of V is equal Q over A. Okay, why? Because the flow rate here can be determined. Means that previously, in our calculation, we could determine the value of total flow rate, and also we already know the flow rate for each nozzle. Okay, so means that the Q is already known, and the value of A here, A is the cross-sectional area, mean cross-sectional area of this delivery pipe. So the equation for the cross-sectional area consists of diameter. So if you look here, so we replace the value of V here with the equation of flow rate. So we could replace the value of V with 4q over pi d square, and we need to square the value because we have a v square here. And then I think you already know that if we substitute all the value here, so we could get the value of D, and the D here is actually the diameter of this delivery pipe. So if you calculate this one, you will have the value of D is 0.85 meter.